Hello everyone, welcome to Abhi online classes. Today I want to explain Rolle's theorem in the chapter Differentiability. Statement is, if a function f of x such that f of x is continuous in the closed interval a comma b, this function must be continuous in the closed interval, and f dash x exists for every point in the open interval. That is, f is derivable, differentiable in the open interval a comma b. F should be, this function f must be continuous in the closed interval. F must be derivable in the open interval a comma b. Third condition is f of a equal to f of b. All these three conditions must satisfy by this function. Then by Rolle's theorem, there exists at least, that means at least one means more than one or more than one. At least one value of x, say c, where c belongs to open interval a comma b such that f dash c equal to 0. In this open interval, there must be at least one value of x, that is c, belongs to the open interval AB such that f dash c equal to 0. This is the Rolle's theorem. All the three conditions must be satisfied by this function. Then only this f dash x is equal to 0. That means f dash x vanishes. Regarding this Rolle's theorem, we should note down two important points. First notice, there may be more than one point like C at which f dash x vanishes. There may be more than one. Already we have discussed, at least means more than one. There may be more than one point like C at which f dash x vanishes. Note 2. Rolle's theorem will not hold good if any one of the three conditions fails. If any one of the three conditions, that means if f of x is discontinuous in the closed interval a comma b, and f dash x does not exist at some point in the open interval a comma b, and f of a not equal to f of b, if any one of these three conditions fails, Rolle's theorem will not hold good. We have to remember these two important notes. Now we'll see some problems. First problem. Verify Rolle's theorem for the function f of x is equal to sine x in the closed interval 0 to pi. Here given function is f of x equal to sine x. Obviously sine x is continuous. In the chapter continuity we have seen is continuous in the closed interval 0 to pi. And it is derivable also. F dash x exists. And it is derivable in the open interval 0 to pi. Now we shall see the third condition of the Rolle's theorem, f of a equal to f of b. In this interval 0 to pi, this is a and this is b. First we put a. F of 0 equal to sine 0. Sine 0 is 0. Now we see f of b. F of b is pi, f of pi, sine pi. Sine pi also 0. Therefore, f of a equal to f of b. This is the third condition of the Rolle's theorem. All the three conditions, f is continuous in the closed interval, f is derivable in the open interval of 0 to pi, and f of a equal to f of b. All the three conditions of Rolle's theorem are satisfied. Therefore, by Rolle's theorem, there must exist at least one value of x, that is c, belongs to open interval 0 to pi such that f dash c equal to 0. Now we find f dash x on differentiating on both sides. F dash of x is equal to sin x derivative is cos x. So it is cos c equal to 0. Cos c equal to, we write this 0 as a cos of plus or minus pi by 2, cos plus or minus 3 pi by 2, cos plus or minus 5 pi by 2, odd multiples of pi by 2. Therefore, c equal to plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2 and so on. But in this interval 0 to pi, there exists only one c. Therefore, c is equal to plus pi by 2. C is equal to plus pi by 2 only lies in this interval. There exists at least one c. This is equal to. There exists at least one value in this interval. Therefore, Rolle's theorem is verified. At least one value or more than one value must exist in this interval. Therefore, Rolle's theorem is verified. Now we shall see another problem. We shall see second one. Verify Rolle's theorem for the function f of x is equal to x power 4 minus 1 in the interval, close interval, minus 1 to plus 1. Given f of x is equal to x power 4 minus 1. This is a polynomial function of degree 4. It is continuous. Every polynomial function is continuous. Is continuous in the closed interval and also derivable, differentiable, or we can call it as differentiable. Derivable in the open interval minus 1 to plus 1. These are the two conditions of the Rolle's theorem. Now we shall see the third condition, f of a equal to f of b. First we see f of a. In this interval this is a and this is b. First f of minus 1. We prepare now. F of minus 1 is equal to minus 1 whole power 4 minus 1. That is even power, no? So minus 1 whole power even number is plus 1. 1 minus 1, 0. F of b. Here b is 1. F of 1 is equal to 1 power 4 minus 1. This is also 1 minus 1, 0. Both are equal. Therefore, f of a is equal to f of b. All the three conditions of Rolle's theorem are satisfied. F is continuous in the closed interval of minus 1 to plus 1, derivable in the open interval minus 1 to plus 1, f of a equal to f of b. All the three conditions are satisfied. All three conditions of Rolle's theorem are satisfied. Then there exists at least one value of x. That x we call it as a c. There exists at least one value of x, say c, belongs to open interval a comma b. Open interval a comma b such that f dash c equal to 0. Now we find out on differentiating on both sides. F dash x is equal to derivative of x power 4 is a 4x cube. Derivative of minus 1 is 0. So f dash x is equal to 4x cube. F dash c is equal to 4c cube. 4c cube equal to 0 implies c cube is equal to 0, which implies c is equal to 0. Definitely this c belongs to open interval of minus 1 to plus 1. So this c lies in the open interval of minus 1 to plus 1. So at least one value of x exists in this interval. Therefore, Rolle's theorem is verified. Rolle's theorem is verified. First we have to see the given function is continuous in the closed interval, derivable in the open interval, and f of a equal to f of b. This is the third condition of the Rolle's theorem. All the three conditions must be satisfied by this function. Then only we should take there exists at least one value of x. Say c belongs to open interval 0 comma minus 1 to plus 1. Interval a is minus 1, b is plus 1. No? So they must exist in this interval. So f dash of c equal to 0 we should take and find out the value of c. By taking f dash of c equal to 0, we can find out c. There exists at least one value or maybe more than one value also. So here there exists only one value in this open interval minus 1 to plus 1. Like this we can verify Rolle's theorem. Hope you understood this class. Thank you.